Hi there, Scott again from EdgeMath. Let's see, just showed you a Prim's algorithm question, but there's a second algorithm for finding minimal spanning trees, and it gives the same result as Prim's algorithm, and it's a little bit different. So if you remember, for Prim's algorithm, we pick a vertex, just any vertex, and we start adding edges from there, and smallest to highest order. But for Kruskals, we're just looking at the edges now. We find the smallest edge in the graph and add it as long as it does not create a cycle. So we're just looking at the smallest edge anywhere in the graph and add it to our minimal spanning tree, and that will give us as long as we add it in a way that we don't add cycles, then that will give us the minimal spanning tree. So let's look at of all these edges, what is the smallest here? It's like 200 from New York to Boston. Is there any smaller? I don't see any smaller. So we add that one. Okay, let's do this in red. So we add New York to Boston. So let's look at the next smallest. Look for the next smallest edge. 900, 800, 500, 300. Looks like 700 between Chicago and New York. That's the. Ooh, no, we've got 500 from Chicago to ATL. So we add that one. Chicago to ATL. So let's list down. So New York to Boston, 200. Chicago to ATL, 500. Let's see, what else can we add? The next smallest up would be 500. It's like 700 from Chicago to New York. It's the next smallest. So we add that. So Chicago to New York, 700. How about the next smallest? Looks like well, New York to ATL is 800. That's the next smallest. But New York to ATL, 800. But we don't add, maybe you see why, because this would generate a cycle. So if we added New York to ATL, that's the next smallest, but we don't add that because that would create this cycle. So it doesn't lead anywhere new if we add that. So we don't add. Also, ATL to Boston, let's see. That's the next 900 is the next smallest, but that also creates a cycle. So we don't add that. So ATL BOS 900, we don't add. So you can make a note that we checked it, but we don't add it. Next up, let's see. Looks like we've got 1,000 twice. There's 2 1,000s. That's the next biggest. So we add. Let's see, Denver to Chicago. That's 1,000. Seattle to LA is 1,000. So we add Denver to Chicago, 1,000. LA to Seattle is 1,000. We add those. Let's see. Next largest would be. Let's see. Looks like we've got 2,900 Seattle to Boston, 1,500 Seattle to Denver, 1,200 LA to Denver. Looks like that's the next smallest, so we can add that one. LA to Denver is 1,200. So LA to Denver, 1,200. And we can keep going on, but we've got all the cities in this, so we've got our minimal spanning tree. So we could, like, if we were to continue, we check, well, Seattle to Denver, that's 1500, but that doesn't add anything new. It creates a cycle if we add that. So you can see if we added that. Right, we shouldn't do that because that creates a cycle. It doesn't go anywhere new. So same with 2100 LA to Chicago, that would create a cycle. So with 2500 LA to ATL, that would create a cycle. And 2900 Seattle to Boston, that would create a big cycle here. So if we were to add that, that would create this loop going around. So we're finished. So we're finished, and then let's see, we can check the total length of this. It's the same. You might remember it's the same as what we got in Kruskal's algorithm. So, or sorry, Prim's algorithm. 1000 plus 1200 plus 1000 plus 500 plus 700 plus 200 equals 32, 37, 40, 4600 miles. So that's our total distance. Is 4600 miles. Great, and that's Kruskal algorithm. So if that everything's clear with that, well, let me know if you have any questions, and hope you have a great day. Scott here from EdgeMath signing out. Goodbye.